What's up, POE? It's Fagan. I'm wearing a hat because it's beautiful outside. I need to protect myself. All right, so I got two comprehension check questions for you based off last week's material, all right, which you can see on my screen. So the first is about this manufacturing processes, all right. Number one, here's the question. Name one manufacturing process that was new for you, okay? You learned from this activity. So that's your first question. Second question is this. For product analysis 221, name which component or part of your product you think is the most expensive to make. Okay, that could be the materials, that could be the manufacturing process involved, like the amount of energy, electricity, all that kind of stuff. Which is the most expensive part to make of your overall product. Okay, so you're going to put your answers to those two questions in a comment on today's Google Classroom post, okay, or this week's Google Classroom post. All right. So moving on to this week. All right, we're at 4:14. This is rolling out on Tuesday because technically yesterday, 4:13, you were supposed to have a day off. So I want to respect that. So that's why you're getting this today. And you'll notice I adjusted the due dates a little bit for some of those assignments. So there you go. Okay, so we're talking about stress and strain this week. All right. So here's our essential question. How is material testing data useful? All right. How is material testing data useful? So if we look at this slideshow here, you can create a graph like this for any material that gets tested. All right. So this side, this y-axis is force. All right. And then this side here is what we call the stress. All right. Actually, I don't think that's right. That would be the strain. It's a strain. So yeah, as you increase the force, what happens to the material and its ability to withstand that force? All right. So that's the question we're going to answer. I'm going to have a separate video, which will be optional, going through this slideshow, kind of slide by slide. But basically, let's look at the two types of stress, main types. All right, the first is axial stress. All right, it is symbolized by lowercase Greek letter sigma. It is defined as a force acting on a perpendicular cross-sectional area. Okay, so we've got our bar, all right, and we're going to pull it apart. Okay, just like we're doing to William Wallace in this scene here. All right, so let's go back to where this starts, and we're going to put him on the rack. I don't think you can hear it, so I'm going to narrate. So yeah, this evil man is tying up his feet. This evil horse is about to pull him. And these evil ropes are going to put him under axial stress. All right? So that's what's happening to poor William Wallace right now. Brief break from the action now. Okay, so that's axial stress. Okay, I know you want to see the more gruesome part. Here it comes. Terrible. The ropes are stretching. Okay. So let's look at what shear stress is. And we're going to use a little clip from The Empire Strikes Back to help us understand that. Shear stress, symbolized by the Greek letter tau, is defined as the force parallel to the cross-sectional area divided by the cross-sectional area. All right, so I've got my beam and I do this to it. All right, that is shear stress. So let's see what happens to poor Luke here, starting right about here.
It is useless to resist. Don't let yourself be destroyed as Obi-Wan did.
He says it is useless to resist. All right, watch. Here comes shear stress. Ooh, those couldn't handle it. Ooh. Nor could Luke's arm handle the shear stress. All right, so yes, that's an example of we've got axial stress and shear stress. Okay, so what about those things? Well, when something goes axial stress, undergoes axial stress, there is elongation, okay? And if we take that elongation, which we would measure in, inches or centimeters or whatever, and divide it by the original unit length, okay? So let's say let's say his body stretched by 1 inch and his original height was 6 foot, so that's 72 inches. If we take 1 divided by 72, that's going to give us the strain. Okay? Your task for this week is to go through 5 of these problems, solve any 5 that you like. Okay, there's 10 problems to choose from. You're going to pick 5. Here's how to do it. Just like any math problem, we want to do these steps. Identify our knowns and our unknowns. They want you to draw a picture here to help you make sure you're doing this correctly. You're putting the knowns and unknowns in the right places, et cetera, et cetera. Pick an equation from your formula pack, which you can find a formula pack in the resources here on my PLTW. Substitute the numbers and units into the equation and solve, and says convert if necessary. You may need to actually do the conversion earlier. All right, but here's the example they give you. A force of 150 pounds pushes on a round plate with an area of 30 inches squared. How much stress does the plate apply to the ground? So we have a known force of 150 pounds. We also know the area is 30 inches squared. Our unknown is the stress. All right, so they drew a picture. They've written an equation. So we've got stress is equal to force divided by area. And then they substitute and solve. All right, so any 5 problems, feel free to contact me on WebEx. I'm available every weekday from 9 to 10. You can also email me with your questions. Yeah, that's about it. Last thing, very optional for you. So an optional video, like I said, will be over the material testing slideshow. I'm going to go through this slide by slide. All right, have a good one, y'all. See you later.